students. In previous lecture we have talked about the acceleration, velocity and speed and types of acceleration. So now in this lecture we will talk about the derivation of laws of motion, about which you guys are already known about the laws of motion. There are three laws of motion. Before going to the derivation, let's discuss a simple numerical. Okay, so you have given a graph. This is VA, so this is A, and this is point B, and B, this is your displacement versus time graph. This is displacement versus time graph. So this angle is given as 30 degree, which is angle of B, slope of angle line B, and second is given as angle 60 degree, that is the slope of line A. So question is asked that you have to find the ratio of the velocities of A and B. Okay, so it is quite easy that we already know. Just note a point here. Slope of displacement time graph, or short form is xt curve, will gives velocity. Okay, it is very important that the slope of xt curve or velocity time graph gives you velocity. So if you talk about the slope of B curve or velocity of B, so velocity of B will be tan of 30. That is the slope. That is equal to the m. M is slope. M is equal to tan theta, and theta is given as 30 degree for the velocity of B. Same as velocity of A will be given as tan 60 degree. So tan 30 is equal to 1 by root 3. Tan 60 is equal to root 3. Now you have to take ratio VA by VB. So VA is what? 1 by root 3, and this is VB is VA is root 3, and this is 1 by root 3. So root 3 will go to the numerator, so it will be root 3 multiplied by root 3 by 1. So root 3 into root 3, that is 3:1. Okay, VA over VB will give you 3:1 ratio. Okay guys, that was quite easy. Actually, I want to tell this important note. Okay, that the slope of displacement time graph will give you the velocity. Okay, so now comes to the main topic. So that is a derivation calculus method. Okay, in class 9 you guys have already derived this equation of motion by the graphical method, okay, or by the simple method, but here we will use calculus method. Okay, for the derivation of the laws of motion. Okay, there are three types of laws of motion, or three laws of motion. First is V is equal to U plus AT. V is equal to U plus AT, and this is called the relation between velocity and time. Okay, in any question, if you have been asked that find out the velocity or find out the time, so you have to use this formula, first equation of motion. Second equation of motion is s is equal to ut plus half at square. This is your position time graph or position time relation. Position time relation. This is your displacement. S is what? Displacement here. And u is the initial velocity, is the time, a is the constant acceleration, and last you have v square is equal to u square plus 2at. This is the third equation of motion, and this is 2as. Okay, and this is the relation between velocity and velocity position relation. Okay, so these are the three equations of motion. Now let's start with the derivation from first equation of motion. First equation of motion. Let's see here. A person is standing at t is equal to 0. At t is equal to 0, a smiley face. Okay. At t is equal to 0, it has initial velocity u. What is u? U is a initial velocity. So after time t, okay, after time t, it covers a distance or displacement s here. At t is equal to t. Now it has velocity capital V, and this is called the final velocity. Okay guys, we know what is acceleration. Acceleration is the rate of change of velocity. Now here the change is time. The changing time is changing, and here velocity is also changing. Here at time t velocity is v and initial velocity was u. So velocity is changing with respect to the time. So body will gain an acceleration a. Okay. So from acceleration we know acceleration is a rate of change of velocity. Acceleration is what? Rate of change of velocity. So just do cross multiply here. So you will get a dt is equal to dv. Okay, any problem? So just integrate both sides. This is the sign of integration. Integrate both sides. Here at the RHS, this is the integration with respect to the velocity. This here, this is dv, means this term is integrating with respect to the velocity. So and this LHS is integrating with respect to the time. A is constant because this term is integrating with respect to time. So acceleration will be constant. So it will come out of the integration. So it will be a dt is equal to integral dv. Now put the limit. At time t is equal to 0, velocity was u, and after spending time t, it attains the velocity v. So at time t is equal to 0, body has initial velocity u, and after time t, it has velocity, final velocity v. Okay, and we know integration formula. Integral x raised to the power n dx, it has formula x raised to the power n plus 1 over n plus 1. Okay, and a constant comes, so you don't need any constant here. So this is a simple integration. So here the integral dt, here written as 1 multiplied by 1, here also multiplied by 1. If the power of any variable is 0, so the value of that term is 1. So in the place of 1, we can put t raised to power 0 dt, 0 to t, and here also integral u to v raised to power 0 dv. Any problem? The value becomes 1 again, so it doesn't make any impact on the expression. So for integration of integral dt or t not dt, here look at here, t raised to power 0 dt, so it will be t raised to power 0 plus 1 over 0 plus 1, it will come t. And same for the v raised to power 0 dv. So here you will get a t 0 to t, and here v 0 to u to v. Now put the limits. Okay, final limit minus initial limit. This is higher limit or final limit, and this is lower limit. So higher limit t minus lower limit is 0. Okay, here final limit is v and lower limit is u. So just multiply here, so you will get at is equal to v minus u. Just transpose u at the left side, so you will get v is equal to u plus at. So this is your first equation of motion. It was quite simple. Okay, just note it down. Okay guys, let's talk about the second equation of motion. Second equation of motion. This is a position time relation. Okay, second equation of motion, and also called position time relation. Position time relation. So from the definition of velocity, what is velocity? It is the rate of change of displacement. Rate of change of displacement. So v is equal to dx by dt. Again cross multiply it. So you will get dx is equal to v dt. Okay. We already discussed about the first equation of motion, that is from first equation of motion, So v is equal to what? V is equal to u plus at. So put this value of v in this equation, so you will get dx is equal to v is equal to u plus at into dt. Okay, so just multiply, open the brackets, we will get u dt plus a t dt. Okay guys, don't multiply this t into this t. Okay, this shows that this is the integral term. This is the integral term, and this is the integrating. This whole term is integrating with respect to the time. So here is dx. Now integrate all the term. So here this is the displacement. So at the time t, all the terms are integrating with respect to the time t. Okay, and what was the limit of time? So at initial time t is equal to 0. When it starts journey, so limit will be 0 to t here at right side, and here this is the displacement. So when we talk about the time, when the time was 0, the displacement was also 0. Okay, and when it attains time t, when it attains the time t, it covers a displacement of s. It covers a displacement of s. As usual, where it is 1 written as 1, here 1 and here u, so it will have integration x and limit is 0 to s. Okay, this term is integrating with respect to time, so u will be constant, it will come out of the integration sign, so it will be u, and integration will be again t, 0 to t plus a, and here integration of t dt, integration of t dt. Suppose t dt is written as, so the power of t is 1, so integration will be 1 plus 1 over 1 plus 1, so you will get t square by 2. So integration of this a t dt is equal to a t square by 2, limit is again 0 to t. Put the limit, final limit minus lower limit, final limit is s and lower limit is 0, so s minus 0, here u, t minus 0 and plus take half common, so half a and t square minus 0. Okay, so simply it will come s is equal to ut plus half at square, ut plus half at square, and this is your second equation of motion. Any problem, guys? Okay, you have third equation of motion. Okay, that is velocity position relation. Now you have third equation of motion. That is velocity position relation. Third equation of motion. And what is this? This is position velocity relation. Okay. So guys, third equation of motion is v square is equal to u square plus 2as. So from the velocity expression, or acceleration, take a is equal to what? dv by dt. Okay, acceleration is rate of change of velocity. You have to just manipulate here and you have to multiply by dx by dx in this velocity or dv by dt term. So it doesn't make any impact because dx by dx is 1. So 1 will multiply in this term and doesn't make any impact on this expression. Okay, so dx by dx. So just take dx by dt together. So it will be dv by dx and here dx by dt. So we know that velocity is what? dx by dt, rate of change of displacement. So in the place of dx by dt we can put v. Okay, so put here, so it will be v dv by dx is equal to a into dx, sorry, v dv by dx and here a. So now you get v dx acceleration is equal to v dv by dx. Okay, so just cross multiply here, so you will get a dx is equal to v dv. Okay, now just put the integration sign and the limit. Got that? Here when displacement was 0, velocity was u, and when it attains or covers a displacement of s, it has a final velocity v. So guys, just it is integrating with respect to the displacement, so acceleration will be constant, so it will come out of the integration, so it will be simply dx or 0 to s. Here it is integrating with respect to v, so v raised to the power 1, so integration will be v square by 2, v square by 2. u to v. Here it will be a x 0 to s. Take half common here, so you will get v square u to v, and put the limit now. So you will get s minus 0 is equal to half v square minus u square. Okay guys, so it will be as is equal to half v square minus u square, and 2 will be multiplied with this term as, so it will be 2as is equal to v square minus u square. Now the u square will goes to the left side, transpose left side, it will be positive, so v square is equal to u square plus 2s. Now you have the final expression, and this is the equation of third equation of motion. Okay, it was quite simple. There is nothing difficult in the integral or calculus method. Okay, so आज के लेक्चर में ही इतना ही. नेक्स्ट लेक्चर में we will discuss about the numericals problems on the basis of these equations of motion. Okay guys, thank you, have a good day.